My name is Lauren Bainbridge, and I chose to do prompt 2 for Module 6. Here we see the wild-type pathway to have spikes on the skin of a lizard. So here we can see that S activates P, which therefore stops the activation of I, which then allows K to activate E, which allows spikes to occur. And here we see our cool little spiky dragon lizard. If there was mutation on the P part of this pathway, then S would activate P, which would then activate I, which would then prevent K from activating E, so the pathway would stop here at I, and spikes would not be formed. Next we look at if there was a mutation on the I. So the S would activate the P, which would then stop the I from being activated, which would allow K to activate E and spikes to form. With a mutation on the I molecule and E, we see that S activates P, which then stops the activation of I, which then allows K to activate E, but since that has been mutated, spikes cannot form. And it stops there. And finally, if there's a mutation on the S and K, the S would not activate the P. Therefore, the I would there be activated, and it would stop the activation of K, which would stop the activation of E, so there would not be spikes. Finally, seeing the different types of things that can be shown by the cells, it poses a question that what type of regulation could explain why not all cells in the skin have spikes, even though they have the same genotype sequences. And I personally believe that this could be caused by methylation. We see here as a pathway these pieces here at the beginning, right here, are not methylated. So it allows the activator to connect to the promoter region and allow transcription of the DNA. However, if these pieces here are methylated, then the promoter cannot bind to the promoter region. Therefore, transcription would not take place and spikes would not be shown in those certain cells. And methylation occurs randomly within the cells.